So hello everyone and welcome to this new course that we are starting from today. Today is the session 1 and the course is design and detailing of RCC structures using RCDC. So before I start, let me thank all of you for joining this course. Many of you have been regular participants at our courses. There are few uh, who have joined after a long time, so it's catching up of sorts. And many are new participants also, those who are taking course with us for the first time. So thank you and welcome to all of you. So I hope my voice is audible. You can see the screen. So just some instructions that you will be kept on mute and you will also not be able to start your videos. So if you want to interact with us or communicate anything to us, you can just write it in the chat box and we will be regularly monitoring the chat box and we will be replying whatever you write or type in the chat box. We'll reply to it. Any questions that you have, you don't need to wait till the end. You can just type in your query, question, whatever. And if the question is relevant, we'll take it up then and there, or else we will wait and take it towards the end of the session. Those who are going to watch this session as recorded session later on, I'll suggest you to watch it at a higher speed. So just like streaming platforms have this option, you can watch it at 1.5x or 2x speeds. Those who are going to watch this session later on as per their convenience. So that actually helps you to save your time. And often in live sessions, we tend to speak little slowly. So when you are watching these sessions as self-paced learning, this feature you can use wherein you can just increase the speed of the video and watch those sessions. Okay. And if you want to, let's say, uh, understand something in detail, maybe you can slow down the speed and watch it at normal pace. Anyway, so let's start then. And this session 1 we will conduct on PPT, but other than that, we will not be having any presentations. We'll be directly using the whiteboard or we will be directly going to the software for discussion. So let me just begin. And what are we going to quickly discuss? There are a few things which are being repeated from the introductory session, but I just thought I'll take it up once again. So we will just discuss what is RCDC and why we thought such a course should be conducted, what is the approach that we are going to adopt, and we will quickly go through the course contents, and then we will start with the iterative process that we usually follow for design. So let's begin. Is my voice audible? Hello? My voice is audible to everyone? Yes. So as you all know, RCDC, wait a minute. Yeah. So what is RCDC? We have discussed this before also in the introductory session, but very quickly. So RCDC, as you know, is a post processor and it has been developed by earlier. Originally, it was developed by SQ Future Tech Private Limited, a Mumbai-based company, software development firm. And then they later on, uh, it was taken. This firm of theirs was taken over by uh, Bentley Systems. So now it's part of the stat package RCDC. You get it as a package as part of your stat pro package, and it's a post processor basically. So when I say post processor, please remember that it will not do any analysis. It will not perform any analysis. This is very important for you to remember, that it will not perform any analysis. It will only take the analysis results, and once it takes analysis results, it will only do the design part. What do we mean by design? So design means it will check the size that you have provided, and it will do the reinforcement calculation. And once you do the reinforcement calculation, it will also do the reinforcement detailing, and it will help you to prepare layout. And finally, you can generate drawings and BOQ. Okay. So this is what basically RCDC will be doing. And since the introduction of 13920, RCDC is also able to perform the ductile design and detailing checks. For example, checks like beam column capacity ratio. Okay. Then your joint shear check. These checks that were newly introduced in the 13920 2016, your design for shear RCC structural walls. So all these new checks that have been introduced in the 13920 2016, all those checks RCDC is able to perform. So StatPro is not able to do these beam column capacity ratios and joint shear. Okay. And neither they are spending any effort, or neither they are putting any effort in enhancing the capabilities of StatPro, isn't it? So Stat is almost I would say a dormant software right now, with nothing much development happening in the software. So they are just, for example, they took over the RCDC, they added RCDC to their platform. And so these ductile design checks are being done by RCDC. Stat is not bothered to carry out these checks. Okay. So, yeah. So RCDC will help us in doing the ductile design and detailing. And as I told you, even though it's a product of Bentley Systems, so obviously it is integrated with STAD, but then you can also take the analysis file of ETABS to RCDC and use it for your design and detailing. Okay. One of the good features of RCDC is that it offers you great flexibility, and there are a lot of options to modify, to change, to set the reinforcement as per the desired arrangement of the structural engineer. So whatever is the wish of the structural engineer, he or she can set it, that arrangement in the software. And according to the set arrangement, then RCDC will be able to give you the drawings, reinforcement detailing drawings, which you can also use directly as project drawings. And RCDC is also able to give you good level of accurate BOQ for the various RCC items. So in this way, RCDC you can use to make your work faster, efficient, and easier, mainly for projects which need repetitive working. You can use RCDC. Obviously, for that, first you need to be uh, you need to have proper knowledge of RCDC, and you need to develop confidence in using RCDC. And you need to be sure of what RCDC as a software is doing, what are its limitations, and what are its um, capabilities, what are the things that it is not able to do, what are the things it can do. All these things are necessary for us to understand before we can start using RCDC for our projects. And that is the reason we thought that we will conduct this course and try to address all these issues, so that once we address these issues, we can then start using RCDC for our projects. So that is the reason we are conducting this course. So through this course, we will have an in-depth understanding about RCDC. Many of you who have joined this course as participants informed us that they have been using RCDC, but then they did not get the time to sort of verify the different calculations, or they did not get the time, or they were not able to spend the effort to verify and to validate all these calculations. So that's why they joined this course. So yeah, that's what we are also going to do, that we will take out time to first understand, discuss each and every aspect of design and detailing of different items like slabs, beams, columns, RCC walls or shear walls, footings, pile caps. We'll understand what RCDC is doing for them, and step by step, each and every calculation we will first understand. That will be the first aspect of this course, to understand what RCDC is doing for the different RCC design, RCC elements. Okay, so that's where we start. And then once we understand all these elements, then we will also learn and try and discuss how the BOQs are being calculated, and the way in which drawings are being generated by the software, and how we can use those drawings for our actual projects also. Once we understand the different RCC elements, then we will take up one project and we will try to apply all the learnings of our sessions to this project, and try to do this project in RCDC as you would do in your design office. So that is the approach we are going to follow, and the approach will be from part to whole. So we will begin with small parts, understand the small parts first with easy examples. Whenever you are understanding anything uh, afresh, you should always start with small parts. Always try to break down your bigger problem into small parts. Understand those small parts first. Once you develop the understanding for small parts, then you integrate and apply those learnings for the whole. So the same approach we are also going to adopt for this particular course. So as I repeated earlier also, that first we will take up the different elements, and once we understand what RCDC is doing for different elements, then we will take up the whole project and do it. Okay. Yeah. So very quickly before we move ahead, what are the course contents that we are going to discuss? So initially we'll start with the basics about RCDC, just a quick run through of what RCDC is doing, basic workings of RCDC. Then we'll begin with importing the analysis files. So as I told you, RCDC is a post processor, so it does not have the analysis. It cannot generate the analysis file on its own. You need to bring that analysis file from some analysis engine like STAD, ETABS, etc. So you'll understand how to import these analysis files from STAD and ETABS. As I told you earlier also, the importing of analysis file from STAD is easy. It's a one-step process because STAD and RCDC are uh, from the same Bentley systems, but bringing the analysis file from ETABS to RCDC can be little bit challenging. It will be a multi-step process because RCDC is not compatible with ETABS as they are products of two different companies. So we'll see those things, how to bring analysis files from STAD and ETABS. So as of now, it is able to support only these two software, STAD and ETABS. In my understanding till now, I don't think any other software analysis results can be brought to RCDC. Can anyone provide any input on that? Other than STAD and ETABS, any other software analysis results, can it be brought to RCDC? I think no. As far as I have understood till now, you can only bring the analysis results from either STAD or ETABS. Yeah. And I guess that those are the two softwares which are used at least in the Indian subcontinent. These two softwares are more used. So that's why maybe they have the capability, RCDC has developed the capabilities to bring the analysis files from only these two platforms. Once we understand the how to import the analysis file, then we will start one by one with the individual elements. So we will start with design and detailing of beams for gravity loads. Initially, we will only take a STAD file, which only, initially we will only take analysis files which have only gravity loads in them, only dead loads and live loads. We'll understand how to do the design and detailing for dead loads and live loads. That means it will be non-ductile. Okay. The design process will be non-ductile. So initially we'll start by this for beams. Once we do the beams, then we will go to the slabs, and slabs also initially I mean slabs usually will only do for gravity loads. So after beams, we'll do slabs for gravity loads, design and detailing of slabs for gravity loads using RCDC. Then we will take up the design and detailing of columns, again only for gravity loads. That means non-ductile. Uh, so when I say non-ductile, which is the code we will follow, or which is the only code we will follow? So we will only follow IS 456-2000. Okay. I heard that the 456 new draft, long awaited draft, is going to be distributed for public comments and public review sometime in the month of May. So that is what May 2024, that is. So that is what I learned from reading some posts on LinkedIn, that uh, they are going to bring this draft for wide public circulation in the month of May. I have been hearing for the past 2-3 years that the draft is going to come for public circulation. So I don't know how much reliable this news is, but that is what I heard at least. Let's see what happens. Uh, but as of now, we have the 456-2000. So when I say that we are going to design only for gravity loads, we will be only using the clauses and provisions as per 456-2000. Okay. Then once we do this, so right now I'm discussing the course contents, what we are going to discuss. Once we do this, then we will take up the ductile design and detailing of beams for seismic loads. So that means now we will have dead load, live load, and EQ loads also. So for this, we will have to follow IS 456-2000 plus we will also have to follow 13920-2016. So both codes in conjunction now have to be followed, and the provisions of both these codes need to be kept in mind for the ductile design and detailing of beams for seismic loads. So this is what we will do next. After that, we will also do the ductile design and detailing of columns and beam column joints for seismic loads. So again, the provisions of 13920 and 456-2000 will be adopted for the ductile design and detailing of columns and joints. And here is where I will be discussing the calculations for beam column capacity ratio, for joint shear checks, for the calculation of confinement reinforcement, for the calculation of capacity shear in case of beams and columns. So all those discussions we'll have over here, and we will verify and see whether these calculations that RCDC is performing, whether they are accurate, are they in accordance with the codal provisions. All those things we will verify and confirm. Okay. So this is what we do next. Then we will be doing, after this, we will take up the design and detailing of RCC structural walls, or what we uh, in colloquial language, what we call as shear walls. So design and detailing of RCC structural walls. This we will discuss for gravity and seismic both together, because mainly if we are providing RCC structural walls, most of the times it is there to take the lateral loads. I mean, obviously you can design only, uh, you can design RCC walls in zones or in locations where you are only doing it for gravity loads. But basically, if you are providing a RCC structural wall, usually it is to take care of the lateral loads more. So this is what we discuss, design and detailing of RCC structural walls. After this, my voice is audible, right? Hello. Yeah. After this, then we will discuss the foundations, different types of foundations, different options that you have for foundations. So you have got the different footing options like pad footing. You have got the option for step footing. You have got the option for slope footing. You have got the option for footing on raft. Footing on raft is not a very good option, but yeah, you have got those options. So we'll see how you can use RCDC for these isolated foundations also. Will you be able to use RCDC for rafts? If you want to design a raft, suppose, will you be able to use RCDC for raft? Tell me. So the answer is no, you will not be able to use RCDC for raft. Similarly, here I should have asked, will you be able to use RCDC for flat slabs, suppose? Will you be able to use RCDC for flat slabs? So again, the answer is no. You will not be able to use RCDC for flat slabs because RCDC, I'll tell you these things later, but RCDC does not use the finite element based analysis method, or I would say finite element based analysis outputs for slab design. It will be using the coefficient approach for the design of slabs. So it's only able to do your two-way slabs or one-way slabs as per the IS 456 codal provisions which are given, and it will only be able to do them using the coefficient based method. So RCDC you cannot use for flat slabs. You cannot use RCDC for rafts. Same reason, because it cannot do the analysis design as per the finite element techniques. So it only uses the coefficient method in case of normal two-way supported slabs, or it will use your simple element, it will only use your beam analogy method for the design of foundations also. So what I'm trying to tell you that RCDC is unable to do these kinds of systems, flat slabs, rafts, etc. Okay. So if you want to do flat slabs, rafts, then you need to go to RCDC FE. Okay, which is a different software. FE stands for finite element. So you need to go to RCDC FE. But then if you want to do flat slabs or raft, just go to SAFE. Okay, don't go to anything else. I think SAFE is one of the best softwares when it comes to rafts, flat slabs, etc. Okay, so forget about RCDC FE. Just go to SAFE if you want to do flat slabs, if you want to do rafts, etc. Okay. Mr. Rishabh is asking, does it design flare column or inclined column? I have not tried it till now. Inclined columns. Flared up column, I don't think it can do because it only takes the uniform cross section. But inclined column, if you have modeled it in STAT, I am yet to check if it is able to identify it as a column element or not. So right now, I don't know. I will also have to check. Flare columns, I don't think it will be able to do because it is only able to take the uniform cross section as I can understand till now. Mr. Jigar is saying yes, it does. It is able to do the inclined columns or flare columns or both. Inclined, yeah. So if you have modeled it in ETABS or STAT, if let's say I show you a section, if I show you a section and these are your slabs, and let's say you have an inclined column over here, you have modeled those inclined columns in STAT or ETABS, and then you bring it to RCDC. If it is able to identify these elements as columns, then it will do. There's not much problem. So as Mr. Jigar is confirming, it is able to do the inclined columns. Obviously, analysis file will be as per the STAT or ETABS that you have done. Okay, very good. So rafts it cannot do, flat slabs it cannot do, and so then what can it do? If it cannot do flat slabs, if it cannot do rafts, Basically, you can use RCDC mainly for your framed structures. For framed structures, I would say it will be very good, very well suited. So RCC frame structure, this will be very well suited. Otherwise, you may have a flat slab system or you may have any system, whatever you are doing. You can just do the beams and columns over here. Okay. And for slabs, you can use a different product like ETABS or SAFE. So maybe if you have a flat slab system, you can do the uh, beams, columns, and walls, structural walls. Okay, RCC structural walls in RCDC. And for slabs, you can use SAFE or any other such software. So these days, I was seeing on television new ad which talks about RCF. I don't know if you have seen it or not. During this IPL matches, I was seeing this ad constantly on loop. So the engineer, I don't know whether he is an engineer or what, he's talking about RCF. That if the RCF is strong, your structure can take any sort of loads. And to make strong RCF, you need to use a particular brand of cement. So that was the advertisement. So this RCF was roof and columns and foundations. Did any one of you see that ad? TV commercial? That if the RCF is strong, your structure will be strong. Yeah. So RCF, I was just thinking that even the advertisement people don't want beams in their structure, isn't it? They are not talking about beams. There is no beam, no mention of beams. It's only roof, column, and foundation. So even I think the advertisement must have been developed in consultation with architects. So they also don't want any beams in the structure. So the advertisement people also did not include beams. They just want the roof and the column and foundation. Anyway, yeah. So if you have got a flat slab building, flat slab structure, maybe you can just do the beam. Sorry, if there are beams, you can take up the beams and you can do the columns. And if there is a isolated foundation possible, you can do those foundations. And of course, you can do the RCC structural wall. Okay, so these elements you can do in the RCDC. Flat slabs, you can do it separately in other software. So this is how maybe you can use RCDC for such structures. Yeah, so design and detailing of isolated foundations. This is what we will do. Then after design and detailing of isolated foundations, then we will take up the pile caps. So for pile caps also, it uses what is called as the beam method for for design of pile caps. It uses the beam method for design of pile caps. So we'll see what is being done, how it is being done. So we'll take up the pile caps also. And then as we had discussed during the introductory session, in many cases when you have got steel structures, for example, you have a shed. Suppose you have a shed like this, maybe made out of plate sections. So in many of such cases, what happens is that this structure is steel, but then the substructure consists of RCC pedestal and then it has your footing. So RCDC has this capability that it is able to identify, even for a steel structure, it is able to identify that this will be your RCC pedestal and it is able to do the analysis, design and detailing of RCC pedestals also. So we will also include this discussion in our course where we will do the RCC pedestals for steel structure. Okay. So this is also what we will be doing. And then once we understand all these elements, then we will take up, no, before that, we'll just have a quick look at the BOQ calculation of various elements, what's happening, how it is being done. We will also be looking at the drawing development and bar bending schedule preparation. This we will club it with each and every element itself. So these two things, BOQ calculation and drawing development, we will club it with the individual elements itself. That means when we are discussing beams, we will be discussing the bar bending schedule preparation and BOQ preparation for the beams. Then and there, when we are discussing for columns, we'll discuss the bar bending schedule preparation and the BOQ for columns then and there, and so on. Okay. So we will club it with the individual elements. And then once all these things are done, then we will take up an actual multi-story project and do it using RCDC. So these are the course contents which I already discussed before as well. I just thought I'll repeat it once again. And these are the IS codes we will be referring to. So it will be IS 456. We'll also refer to IS SP34, which is the detailing code. For the column calculations, we will also refer to IS SP16. And when we are doing the ductile design detailing, we will refer to 1893 Part 1, 2016 and IS 13920, 2016. So this is what we are going to basically be doing in the sessions onwards, in the sessions that follow. All right. Very good. So, and obviously we'll be using ETAB StatPro as our software from where we will be taking out the analysis files. RCDC is what we will be using mainly, and Excel spreadsheets we will be using when we want to verify results. When we want to, let's say, verify the results to save our time in doing manual calculations, we'll be using the Excel spreadsheets and some uh, some Excel sheets will be using basically to verify the results. One thing I should have mentioned over here, that RCDC is also able to do the crack width check. All right. So crack width check also RCDC is able to do. So that part also we will try to cover. I'll show you what and how the crack widths are being calculated, and we'll try to compare it with our manual calculations also. RCDC is also able to do the water tank structures or liquid retaining structures, but as of now, it is able to do it for Euro codes. So therefore, we have not included water tank structures in this particular course. Very good. So moving ahead, I'll just like to explain you, in all our courses we take up this point, but it's important that we understand this point before we move ahead. So let us discuss the iterative process of design. Before I go to the iterative process of design, let me just ask you that what do you understand by RCC design? When I say that I have to design this particular element, what do you mean by it in the context of RCC? So for reinforced concrete structures, when I say that I want to carry out the RCC design, what do I mean by it? Very quickly. So basically, what do I mean by RCC design? That first of all, I would like to finalize the size. Yeah. So whether it will be, let's say, 300 by 500, or if it's a column, what the size will be, 750 by whatever. So size finalization comes first, correct? This is what you want to do, finalizing the size. Next, you also want to finalize the reinforcement. So you need to calculate the reinforcement. Hello, are you with me so far? So you finalize the size, then you also want to calculate the reinforcement, the area of steel required. It may be area of steel in compression, it may be area of steel in tension, whatever it is, but it is reinforcement calculation that we want to do. When you are doing steel structures, you just have to do this size finalization for the steel cross section. But here in case of RCC, we need to first, or we need to sort of finalize the concrete size, concrete cross section size, and then we also need to think about the reinforcement calculation. What else do I need to do when I say that I want to carry out RCC design? So not only reinforcement calculation, but I want to understand the direction, the position, and its layout. Yeah. So only reinforcement AST calculation is not enough. You need to understand the direction, in which direction you are going to place it, what shall be the position, which face it will be, what shall be the layout, what shall be the bar arrangement. All those things also you need to be able to calculate, and that is also a part of my RCC design. What else do you want to do? So you also need to, I think I will include it here itself. I also need to find out the bar dia, okay, and bar spacing or bar numbers. So this also I want to calculate, and this also is a part of my RCC design. So when I say I want to do RCC design, mainly I am looking at doing these four things. I should be able to finalize the size calculation. That means the reinforced concrete size, cross section size I need to finalize. I should be able to calculate the reinforcement requirement. I should be able to calculate the bar dia, spacing or numbers, and then I should be able to work out the direction, the position, the layout of that particular reinforcement. When I am able to do this, then I will say that I have done the RCC design. Now, what do I mean by the iterative process of design? So let's discuss what is meant by the iterative process of design. Just keep in mind that the size of that cross section is an important component in the iterative process for design. Okay, just remember that out of all these four things, the size of cross section is an important component in this iterative process of design. So what is that iterative process of design? So basically you make your model. That model is representative of your actual situation. So you make that model, you do the analysis, but when you do the analysis, because all analysis that is performed is stiffness based analysis, you need to provide the sizes of each and every cross section. Are you with me? Hello. Sizes of cross section is required before we do the analysis. So only when we have the sizes with us, only then we are able to carry out the analysis. If I don't give the size of cross section to the software, it will not run the analysis. Why it will not run the analysis? Because these analysis are stiffness based analysis. That means in order to carry out the analysis, it will require the stiffness of the member cross section. Only then it can run the analysis. So unless I give the cross sectional size, analysis is not performed. Okay. So that is an important problem that we have as structural engineers, because as you all know that this was my desired output, isn't it? The size of cross section was my desired output. This is what I wanted. This is what I just had explained, that when we are doing the what do I mean by design? To find out the size, to finalize the size. So this is my desired output. When I am doing the design, I want to finalize the size, or I want to find out the size. And here I am saying that as part of your, just a minute. Here I am saying that as part of your iterative process of design, you will be required to, just a minute. Wait. There is no undo option, redo option, control Y. Anyway, so as part of design, here I am saying as a part of your iterative process, here I am saying that sizes need to be given to begin with. Otherwise, analysis is not performed. So that is a big so that is a tricky situation that we always find ourselves in, that the required output that we wish to have, that itself becomes an input for the process. Okay. So I hope you understand the problem with it, that this was my desired output. I wanted to find out the size of the cross section, but here it itself becomes the input for the process. So it's a tricky situation that we find ourselves in. And therefore, to begin with, what do? We assume certain sizes, isn't it? We assume sizes. We assume the size. We carry out the analysis. When we get the analysis results, then we, in design, basically what we are doing, to begin with, we are checking the sizes. Are you with me? Hello? Quick yes, no. So when I say that once I get the analysis result, our first step is to check the sizes that we have already provided during the modeling. And why did we have to provide sizes during modeling? Because otherwise your analysis cannot run. Is this clear so far? Right. Now suppose this size that I provide, the size that I provide is not sufficient. So I did the modeling, I did the loading, etc. everything. Then I did the analysis. Then in the process of design, my first step was to check the size that I have provided. So I checked the size and I found out that the cross section size is not sufficient. Then what do? Hello. So suppose that means, I know all of you know this, but let's have a discussion for before we start. So suppose I had provided a 200 by 500 beam, okay, in my model. And then for whatever structure it was, for a particular member under discussion, I had provided a size of 200 by 500 and I did the analysis. Then while checking that particular beam, I found out that this size is not sufficient enough. So I, I could see that 200 by 500 size will not work and I will require a 200 by 700 beam size. So then what do? Do I directly change the size and provide this? And is that done? Or do I need to do anything else? Hello. I hope the question is clear. I'm saying that my size in the model was 200 by 500 and then I provided this size. Okay. I did the analysis and then in the process of design, my first step is usually to sort of finalize the size that I have provided, to check the size. So I could see, or I could figure out that this 200 by 500 is not sufficient. I need to increase the size to 200 by 700. So is this done? Should I now go ahead and find out the reinforcement and do the detailing, or do I need to do anything else before sort of preparing the detailing drawings? What do you think? Hello. No answer from anyone. Is the question understood? My question is that if the required size during modeling, I find it to be insufficient during the checking of the design part, I I take this size and move ahead for detailing, or do I need to do something else? So as Mr. Rahul is saying, he is saying that we need to go back and run the analysis again. This is very important. Why do we need to run the analysis again? Why do we need to run the analysis again? Okay, before that, let me ask you one question. Suppose I have a beam 300 by 700 and it's a simply supported beam. Let me ask a quick question. And it is subjected to some UDL of whatever value you want to take. Okay, let's say 10 kilonewton per meter. The span is 8 meters. So I get a particular bending moment for this beam. It's a simply supported beam, assume it to be. Now if my bending moment is, let's say, some bending moment 1, okay, for this particular size. Now if I change the size to 200 by 500, the bending moment that I get, will it be same or different? Will it be more or less in this case when I change the beam size to 200 by 500? Forget about the bending moment due to self-weight right now. Okay, just answer this question for only this particular applied UDL. Don't worry about the self-weight bending moment. Just tell me whether it will be same or will it be different or it will be less, more, what will happen? So when I change the beam size, are my analysis results changing? So we have got few replies. Some are saying the answer will be same. Mr. Rahul is saying it will be different. Will it be same or different? It's a simply supported beam. Cross-section size for first case was 300 by 700. Then I changed it to 200 by 500. Same or different? So what is the bending moment answer, by the way? Bending moment will be WL square by 8. So if my span is 8 meters, what am I looking at? WL square by 8. So 10 into 8 into 8 upon. So in the formula itself, you will see if it's a simply supported beam, the bending moment formula is WL square by 8. Does it have any term which is dependent on the cross-sectional size? Hello? Does it have any term which is dependent on the cross-section size? No. So that means that the bending moment will remain the same. Are you with me so far? So whether I change the cross-section or I don't change the cross-section, if my span is same, if my load is the same, forget about the bending moment due to self-weight. My bending moment value remains the same. I will take another example. So if I take a cantilever beam and let's load it with UDL 5 kilonewton per meter and it's a 3-meter cantilever beam. And again, if I ask you that my size was, I had taken a 200 by 600 size, okay, and then I change it to 300 by 500. Now tell me bending moment, same, different, less, more, what will happen? So when the size was 200 cross 600, and suppose I was getting some bending moment 1, and for this 300 by 500, suppose I was getting some bending moment 2, will this be same, different? What will happen? Tell me, please. Hello. Yes, please. Bending moment. No one knows? I was expecting you will know this. All of you are masters, postgraduate people, experienced people. Same. Mr. Rishabh is saying bending moment will remain same. Same. So in this case also, what will happen? If you look at the formula for bending moment, let's say cantilever beam subjected to UDL, the formula is WL square by 2. So again, you see over here that the analysis result is not dependent on the cross-section size. Then why was Mr. Rahul saying that the analysis result depend on the cross-section size? Hello. Why was Mr. Rahul saying a few minutes before that the analysis result depends on the cross-section size? So was his statement incorrect? So do analysis results depend on the cross-section size? Okay, I'll take another example. Mr. Rishabh is saying in software it will change. What are you saying? So you are saying if you take a cantilever beam in software and if you change the cross section, the moment will change. Again, I am repeating, I am not talking about the moment due to self weight. Okay, it will obviously change because the self weight changes. Moment due to self weight will obviously change. But do you think the moment due to, let's say, a live load component which does not involve self weight, will the values change or not? So they won't change. The analysis result for a cantilever beam or for a simply supported beam will remain the same. Then why was Mr. Rahul saying that the analysis result change with the change in cross section? Why was he saying so? Okay, if I take a portal now, let me take a portal system. So if I take this portal system and let us say these are the sizes. So this is 200 by 500 and then this is 300 by 900 and then okay, this is my portal. Obviously same dimensions, everything same. And I take another same portal, same dimensions, but same loading obviously, but I change the size. So here I make it 200 by 400 and here I take it 200 by 300 and 200 by 300. Okay. So my portal geometry is same, loading is same, but what I have done over here that I have changed the cross section sizes now. Now do you think the analysis results will change? Hello. What do you think? Will the analysis results now change? Yeah, support is fixed, let's say. Will the analysis results now change? So now the analysis results will change. Analysis results will change now, and it has nothing to do with the effective length, what Mr. Rishabh is saying. Now, basically, if you remember these formulae, all these formulae depend on the EI term. Do you remember when we used to do the moment distribution or any method? So they used to depend on the EI. Okay. So EI means E is modulus of elasticity. I is the moment of inertia of this cross section. So what I'm trying to tell you that in indeterminate systems, when you have an indeterminate system, the moment values or the analysis outputs depend on the cross section size. Do you follow? And this is more applicable for the bending moments. This is more applicable for the bending moments. Okay. So the in indeterminate systems, the analysis result will depend on the cross section size. When you have a determinate system, by determinate system I mean system like a simply supported beam or system like a cantilever. So in determinate systems, the bending moment values do not depend on the cross section size. Clear? So in our general structures, which are indeterminate because there are a lot of high degree of indeterminacy in them. So if I am talking about a general structure, which is usually going to be an indeterminate system, on changing the size of beam, if I ask you once again, will the analysis results change or not? Changing the size of beams, columns, member size basically. So changing the member sizes, will the analysis results change or not? So the answer should be yes, they will change. So answer is yes, they will change. And therefore, when I'm carrying out the design in RCDC, let's say I figure it out that this size is not workable or this size is not sufficient or the reinforcement required for this size is too high. I need to change the size, let's say. So then I need to change the size. Okay. Let's not go to RCDC right now. So I did the modeling. I took this 200 by 500 beam. I run the analysis. Then while checking the design, I could figure out that the size is not sufficient. So I increase the size. Then ideally I should go back. I should go back to my modeling. I should change the size. I should rerun the analysis. On rerunning the analysis, what I will see, I will see that the analysis results will have changed. Why analysis results will change? Because they are based on the stiffness of the cross section. So now because my beam size was increased to 200 by 700, my analysis results will change. And now when I carry out the design, I need to check the new forces moments, and for those new forces and moments I need to check this size. Do you understand? Quick yes, no? Hello. Then maybe I may find that now the even the size 200 by 700 is not working. Why it's not working? Because my analysis results now changed, meaning thereby that even 200 by 700 is not working. So maybe I will have to change it to, let's say, 200 by 750. Go back to modeling, change the size to 200 by 750. Then once again run the analysis. After running the analysis for the new analysis forces, then I need to check this size again. And maybe here I get the convergence that I am able to say that yes, now for this cross section that I have provided, my provided size and the analysis forces, I am able to make them pass the checks, and therefore this size is now sufficient. So this is the sort of iterative process that you have to carry out. Okay. So sometimes this may involve a multi-step process. That means in one iteration, you may not be able to do it. So what does that mean? So suppose you took 200 by 500, and this example I always take in most of our courses because most of our courses are based on design. So as an engineer, you should be able to understand this iterative process of design very properly. So what will happen that let's say you had provided 200 by 500, you did the analysis. While checking the size, you figured out that this is not sufficient. Okay, then you change the size to 200 by 600. Okay, then you went back, you did this again. While checking, you could see that even this size is not sufficient, 200 by 700 maybe. Again you went back, did this, and maybe then you got 200 by 800, which was the size that was sufficient and it passed all the checks. So then you said that now this is my size that I am going to finalize, and then you move ahead for reinforcement detailing, etc. So after maybe 2 or 3 iterations, you are able to finalize this size and its reinforcement. Is it clear? It may happen in the reverse way also. This iteration sometimes may happen in the reverse way also. What does that mean? This means that let's say I had a small beam, not very heavily loaded, uh, but I had provided a very large size to it. So then I run the analysis, I do the design. While checking the size, I find that the reinforcement that I'm getting is very low. Okay. I find that the reinforcement I'm getting is very low. So it is safe, but it is turning out to be uneconomic. Okay. So before I move ahead, let me just also discuss this term that as a designer, we not only want to provide safe design, but our design should also be economic. Are you clear? Therefore, instead of using safe or economic, we will use a term which we will call as the optimum design. So our design, we should be targeting towards optimization. So suppose I am providing a G+1 structure, 3 meter by 3 meter is the base size. Without doing any design, do you think 1000 by 1000 mm column will be sufficient for that? 4 columns, 1000 mm by 1000 mm. Do you think they will be sufficient for a G+1 structure, 3 meter by 3 meter base size? Yes or no? What do you think? Uh, you have not carried out any design, no loading, no analysis. Just if I ask you this, will it be safe? Will a column size of 1000 mm by 1000 mm be safe for a G+1 structure which has a bay size of 3 meter by 3 meter? Will it be safe? It will be safe. It will be safe, but it will not be economic. So therefore, we just don't have to think only about safety, but we also have to think about the economics. When I say that I will provide a 100 mm by 100 mm column size, it's economic, it's very cheap, isn't it? It's very cheap, but it may not turn out to be safe. So as a designer, we all have to think about safety plus economics both. That's why we'll usually be talking about the optimum design. All right. So let's not only focus on one aspect, but focus on both the aspects. That should be the job of a structural engineer, to work out optimum solutions. So what I was trying to tell you, that I suppose I provide a 200 by 800 mm size. It's a small span, not very heavily loaded. And while checking the size, when I find out the reinforcement, etc., I can quite clearly see that this size is safe, but it's over safe, as we usually say. So I can change the size. I can make it more cost efficient. I can reduce the size. So again, if I want to reduce the size, I cannot directly just change the size and go for reinforcement. So I just cannot reduce the size and go for reinforcement detailing. Again, I have to go back, change the size, run the analysis, and then check the new size. Maybe I can see that even a smaller size is possible. So I again go back, do this step. Again, I will keep on doing it until I achieve an optimum sizing. So this optimization or this iterative process, so to say, can work in both directions. That means there may be a situation when I have provided size which is unsafe. So I keep on increasing the size till I achieve safety. And for that, I need to do this iteration repeatedly. I have to go back to modeling, change the size, run the analysis, check the new forces. This keeps on going until I achieve convergence. My size is safe, or it can run in the different direction also. That means initially I have provided a size which is much safe, over safe, so to say, and then I run this iterative process of design to achieve an optimum size. Okay, I reduce the size so that it is just safe and it is economic as well. So this iterative process of design can run in both directions. What I want to tell you here is that whenever you do any design, it will be iterative and it has to follow these steps, that you choose a size in your modeling, you run the analysis, check that size. If it's over safe or unsafe, whatever it is, you go back to modeling, change the size, run the analysis again, and repeat this process. Why I'm telling you all this? Why am I telling you all this? Who can tell me? Why did we spend so much time discussing this? So the reason why I spent so much time discussing this, that now when I'm doing RCDC, I think some of you will be able to identify a crucial problem that we will face when we are doing RCDC. Can anyone tell me a crucial problem? Is anyone able to figure out one problem that we will be facing when we are doing RCDC? Tell me. No. What are you saying? So this whiteboard that you see is a new whiteboard feature that is in Zoom. I was what should I say? I was given this feedback that I should be using uh, Microsoft OneNote for taking the for writing down the things. But I think this Zoom whiteboard is a better. It has better options. More about it has better options for drawings at least. So when I want to make drawings, there are good features that are available that are not there in this. What do I call in Microsoft OneNote? And I think they have made this even better now. The whiteboard feature. What all things are you able to see right now on this whiteboard? What all things are you able to see on this whiteboard right now? I can see some cursors that are moving. Everyone is moving their cursor. I don't know why. So are you able to see this title over here? This title on the top left, are you able to see? Yes, no. This title. Yes. Okay. What else are you able to see? I think this top right corner, are you able to see over here? I think this may not be visible. And then Control C. Are you able to see this comments? No. Now are you able to see this comment? This comment on the whiteboard? No. Okay. No. So Mr. Jigar had typed no. This no you are not able to see. All right. I'm also testing this because this whiteboard, they have just upgraded it. Wait a minute. Comments. Ten people are following you. Timer. Are you able to see the timer? This timer, are you able to see? No, zooming out does not help. Timer also you're not able to see, right? No. Okay, very good. No, I'm just taking a feedback of what's happening because it's a new whiteboard feature. Anyway, why I'm telling you all this? Because of a crucial problem that we'll be facing in RCDC. Just understand this very carefully and just understand this very properly, all of you. A crucial problem that we'll be facing in RCDC is what? So as I told you that the stop moving your cursors, everyone. So as I was telling you, the sequence that happens is that we run the modeling, we do the modeling. Okay. After the modeling, we do the analysis. After the analysis, we go to the design. That means we are going to check the size that we have provided. Let me use color. Yeah. So check the size. All right. And if that size is insufficient, obviously we'll go back and change the size in modeling. Now tell me what will be a crucial problem in this RCDC that we are going to face. Yes, please. Anyone? Yes, crucial problem in RCDC that we are going to face. So a crucial problem is, please understand, very important. RCDC is only taking the analysis file. Okay. So suppose I had taken a 200 by 500 beam, and then I run the analysis, and I could see that this size is not changed. This size is not sufficient. So I could change the size to, let's say, higher size. In RCDC, you do have the features to change the size. But then what is the problem in RCDC? What is the problem in RCDC? I'll be able to change the size. I have the feature to change the size. But then the problem is very important, that RCDC is only starting from the analysis. It's only taking your analysis file. Okay. It's only taking your analysis file. So suppose I change the size in RCDC. RCDC does have a feature to change the size. Suppose I change the RCDC size, change the size to 200 by 600 in RCDC. Will it be able to change the analysis forces? Will it be able to change the analysis forces? Yes, please. So it will not be able to change the analysis forces. This is extremely important for us to understand. Okay. No analysis forces will be changed. Why? Because it has no link up with the, it is unable to perform any analysis on its own. So it cannot change the analysis results. So that means that if you change the size to 200 by 600, basically it will check the new size for the old analysis results. It is unable to update the analysis results. Did you understand this very important point? So when I change the size, RCDC is unable to change the analysis results. Okay. So even if you are changing the sizes, the new sizes will be checked for the old analysis forces. Is this point understood? Hello? Yes, no? So I'll write down sizes are checked for old analysis forces. So that means you have to be very careful about this thing, that if you are changing the size in RCDC, because RCDC does give you this option to change the size. So if you are changing the size in RCDC, be very careful that you should update this analysis file and recheck the size again. Is it clear? So there are features to update the analysis file. So it's very important that if you are going to change some sizes, you update the analysis file and then recheck the results. So that becomes a slightly tricky thing to do. Okay, that will become a slightly tricky thing to do, but we'll be doing that. So this is important that you need to understand that because RCDC is unable to do the analysis on its own, when you change the sizes in RCDC, be very careful that you should also then change the analysis file and then recheck the sizes. We'll see all those things later on, but one very important thing that you must understand at this point before we start the course. Clear? Good. So I just wanted to tell you this thing about the iterative process of design, and a crucial problem that we will have in RCDC when we are going to change the sizes to check a few things. Also, one more thing, that RCDC will not be performing any serviceability based checks for you. Clear? So except for footing design, where it will perform the serviceability check for pressure calculation, RCDC will not perform any serviceability check. Clear? Cracking it will do, of course. So deflection checks it will not perform. Are you clear with this? Hello? Yes. So if you want to perform deflection checks, etc., you do it in your STAD file or ETABS file itself. Don't rely on RCDC for that. Clear? Right. So I think this is what I wanted to tell you. The crucial point being that please remember RCDC, when you are changing the size, please be very careful that you need to ensure that the analysis file should also be correspondingly changed. And we will see how that process is to be followed. Any questions till now? Anything that you want to ask? Anything that you want to ask till now? Hello. Okay then. So what do we have? Okay, so now what we will be doing is, Mr. Rishabh is saying, when we design a structure, for what age do we design? Age. Usually age-based calculations are not given in IS 456. They say that it is done for 50 years, but specific age-based calculations are uh, not available in the usual 456. Okay, right. Uh, all right. So now what we will be doing is we'll be starting with this. We'll be starting with this first STAD model. And can you see this STAD model on your screens? So this is a practice model that we will be using. Hello, are you able to see the STAD model? So this will be the first point of order. We would like to bring this very simple. Don't worry about the complexity of STAD model right now. Our first goal is to be able to understand the basic elements in RCDC. So that's why we have kept the model simple, because if we complicate the model, we will miss out on a few important things that we need to understand. So it's a simple model that we have prepared. And what we have done for this, the dimensions. What are the dimensions? Wait a minute. Note to note tools. So what do we have over here? Yeah, 8 meters is the grid. In this direction, it is 5. The story height, we have kept it as 3 meters. All right. So this will be your footing level. Wait a minute. Right. So this is your footing level. Then this will be sort of your ground floor level. This will be your first floor level, and call it the roof floor level. Okay. For each floor levels, what we have done, let me just show you. So this first model, we have only applied the gravity loads. So this is the framing plan at my ground floor. This I am calling it as the slab on grade floor for me. So this is what it is at the ground floor. Then when I show you the first floor, so this is my first floor. And for first floor, I have got these secondary beams provided. Wait, what I will do is, uh, I guess I'll show it with columns also. Like this. Yeah, this is better. Okay. So for the first floor, you will see this is the framing plan, something like this. Yeah. So these you can call them to be You can call these beams to be the secondary beams. So these will be my secondary beams. All right. All other beams are primary beams resting on columns. And I have taken cantilevers over here. And then these are the beams which are resting on the cantilever. So this is the framing that I have got at the first floor. And then I have got another floor which has the same framing plan. So if I show you this floor also, this is our first sort of sample that we have created. This is the framing at the top floor level, same framing. Now, what sort of loads have we applied? So to begin with, I have applied the following loads, which I'll just show you on the screen now. Where are we? Analytical modeling and whole structure. Loading. Yeah, let's go to loading. And I have just applied dead load and live load. I have made only one combination, 1.5 dead load plus 1.5 live load. And the loads have been defined using the reference load option. So self-fed has been assigned to all. The wall loads, we have applied 12 kilonewton per meter wall load at these two levels. At these two levels, we have applied the 12 kilonewton per meter wall load. And if I want to just show you how it has been applied on each floor, let me select one floor for your understanding. So you can see how this 12 has been applied on the periphery and on these internal beams. On the secondary beams, as of now, I have not applied any wall load. Okay, wall load has been applied like this. Then I have applied a floor load. So I have not modeled the floor slabs as such. I have just modeled I have not modeled the floor slab, but I'm going to take the load based on the yield line theory. So that's how this floor load option works. It distributes the load to adjacent beams on the basis of the yield line theory approach. So this I have applied it as 5.25. Why this 5.25? 150 mm slab. So the weight of 150 mm slab will be what? Uh, what will be the weight of 150 mm slab? 3.75. And adding a floor finish of 1.5 to it further, I have applied a 5.25 kilonewton per square meter floor finish load. Clear? And then the live load that has been applied is 5 kilonewton per meter square live load. This is what we have done at the middle floor. And if I talk about the roof floor, what I have done is that at the roof floor, we have applied a 4 kilonewton per meter brick wall load. Let's say it's the parapet wall load. And we have applied the parapet wall load on these beams as well, on the cantilevers also, parapet wall load. And this is the floor finish plus slab self weight, 5.25. The live load applied on the roof floor is 1.5 kilonewton per meter square, assuming it to be accessible floors. Okay. And then if I just show you the ground floor, now because the ground floor was slab on grade, so we have sort of simulated the effect of the slab on grade. That means there will be filling over here. So this slab will be resting on the compacted earth, compacted soil. So therefore we have taken only 20% of floor load over here. And that's why I applied the load as 1.05, which is 20% of the 5.25 kilonewton per meter square value. From where am I getting this 20%? So there is no codal provision as such, just a value based on experience that I'm saying that majority of the load will be taken by the compacted earth below this because it's slab on grade. So I have applied only 20% of floor loads and transferred them to these beams. I'm assuming 80% of the floor load goes directly to the earth because of the compacted finish, compacted earth, compacted soil. So therefore 20% And in live load also, I have applied only 1 kilonewton per meter square. Again, 20%. Srinivas ji is saying, can we apply floor springs? Yes, you can, but then you will have to model the slab elements also. So right now, I don't want to complicate things because the intention is to learn RCDC. So I'm keeping my stat model simple. So live load, I have applied it again 20%. So in 20% of 5 kilonewton per meter square, we have applied 1 kilonewton per meter square live load. Wall load, I have applied full, even though beams are resting on the compacted earth, but because I want to ensure that my beams behave properly and work well, even though it will mean that I am doing slightly conservative design, still I have applied the full wall load on my beams because I don't want because I don't want to completely rely on the floor compacted earth. So that's why I have applied the full wall load over here. Okay, clear? What are the releases? So this is a simple model, simple dead loads, live loads, and then we have taken the reference load over here, and we have just made this combination 1.5 live load plus 1.5 dead load. And the releases that we have applied are only on the secondary beams, and we have only applied the moment release right now. So simple releases that you can see, these were my secondary beams. So I have released the major direction moment about the major axis has been released. Do you get it? So this is a simple model which we will be taking to RCDC and starting our work. And yes, same model has been prepared on ETABS also. Same to same model has been prepared on ETABS also. And in tomorrow's session, we will be first understanding how to take these models to RCDC. So we have prepared identical models in ETABS and STAD. Through this exercise, we will also be able to compare and cross-check the results both of these softwares give you. So that is another intention of doing it. So yeah, so that's what we are going to do. But all these things will start from tomorrow. So tomorrow when we meet in the next session, this will be our starting point. This will be my STAD model, and we'll try to first take it to RCDC and see what happens when we take any model to RCDC. Okay, so that is going to be the starting point for tomorrow. I will stop over here for today. Thank you, everyone, and we will see you tomorrow. Bye bye. Thank you.